introduction, and we'll just get right to it. We don't have a lot of time. So as he said, I'm with Microsoft. Currently, my role is Premier Field Engineer. I support several different customers, and I do a lot of training and education and stuff like that as a Premier Field Engineer. But I have been in CSS before and done a lot of deep technical cases and stuff like that, and I was specifically on the AlwaysOn escalation team for 3 years. So I've been playing around with this stuff for quite a while. Do any of these quotes sound familiar to you? My availability group just failed over. Why? My AG didn't fail over. Why not? I don't know how to figure it out. Or I know where to look, but it doesn't make any sense. So we're going to talk about all of these today, and I'm going to give you some homework as well. I've got several different scripts and some case scenarios for you to study and go through that I'll be passing out as part of the slide decks and the scripts that we give. So here's our agenda. We're going to discuss the most common issues for failover. We're going to talk about the SQL Server and cluster components and their relationship. I'm going to share my approach to root cause analysis, and as anybody who's had to do root cause analysis knows, usually answering the first why question isn't enough. It's usually an iterative process. So we won't go to the nth degree on this stuff, but I'm going to make sure you understand how at the SQL and cluster layer, what was the issue and why they did what they did. And then there could be other factors involved for the ultimate root cause. It could be antivirus, or it could be a NIC card, or whatever. But we'll take care of it from a SQL and a clustering perspective. And we're going to look at the logs. And if you have any questions as we go through, please feel free to just ping them, or if you're on voice, go ahead and blurt them out. We'll take them. So the most common causes for failover, and I've put this together after having done literally thousands of cases of always-on calls coming into Microsoft. I kind of accumulated and kind of did some metrics. These are the most common causes: quorum loss in the cluster, a lease timeout, and we're going to go over all of these, so making sure you understand what they are. A health check timeout, SQL dumps, and user initiated. We don't want to forget that one as well. Sometimes everything was just fine with the system, but somebody failed it over and doesn't want to admit it. Okay, the most common causes for a failover not happening, or basically failure to fail over: one or more of the databases are not synchronized, the secondary is not connected, the failover cluster OS cluster can't connect to SQL, the availability group is actually set for manual failover, or you have exceeded the failover thresholds in your cluster configuration properties. There are specific failure and retry counts that OS cluster resources have, and if they're exceeded, the cluster basically just goes to sleep. And so you have to be aware of those as well, and you may have to tweak those configuration settings. So let's talk about how the SQL Server interacts with the cluster, because basically we have to have a good, thorough understanding of what is going on with SQL and with the cluster, because the way we did things, as most of you know, I'm sure, always-on availability groups are kind of an evolution of database mirroring. We liked database mirroring because I could have a second copy of the database that I knew was always in sync, and I could fail over to it if I needed to. It was like real-time log shipping. And mirroring was great, except that I had to deal with host name changes when I failed over. I had to change the DNS entry, or I had to change my connection strings, something like that. Well, with availability groups, we decided, hey, why don't we use OS clustering, because they know how to handle virtual names. We're well experienced with that with failover clusters of SQL. So if we point our applications to a virtual name managed by the cluster, then we don't have to worry about name changes when we fail over. Great, so we have availability groups. But in that process, we said, well, if the cluster is going to manage this virtual name for us, we might as well have the cluster do all the arbitration for us as well. Remember, in database mirroring, we would have a principal, a mirror, and a witness if we wanted to have auto failover, and two of the three always had to agree. And that would constitute kind of our quorum, quote unquote, in the old mirroring world. Well, with OS clustering, OS clusters are designed to deal with arbitration and voting. That's one of the fundamental factors of OS clustering. So we offloaded all of that voting and communication stuff between the principal and the mirror and the witness. We offloaded all of that to the cluster. What does that mean? Always on availability groups heavily depend on the cluster now. The cluster tells SQL if it's primary or secondary, and the cluster tells SQL to bring the availability group online or offline. SQL cannot bring a database online by itself. It has to be told by the cluster to do that. And that's why the cluster becomes so important, the OS cluster becomes so important in an availability group architecture. A lot of that process is done through the RHS process. RHS is the Resource Health Service. It's part of Windows clustering, and it monitors the health of every resource in a cluster, whether that's an IP address, a name, a print queue, if it's a print cluster, Exchange, if someone still had Exchange, SQL, any kind of resource in a cluster. The RHS process is monitoring it and making sure that it's healthy. If RHS determines that it's not healthy, then we're going to have problems, and the cluster is going to make some decisions and do things. The other piece that we have in these interactions between SQL and the cluster is the RHS process creates a lease with SQL Server on the primary. And we'll go into what a lease is here in a little bit more detail in just a minute, but it's a second way to try to avoid split brain. If anybody's ever heard that term before dealing with a cluster, split brain is basically when we've got two different nodes, each thinking they're the primary. We want to prevent that at all costs, because then we can have data loss. So the RHS process, in an extra effort to make sure that we don't ever get into split brain situations, we have a lease mechanism as well that goes on between the OS cluster and the primary of the availability group. If the OS cluster service stops on a given node, or specifically on the primary, the availability group is going to go offline. Now, if the node is a secondary and it goes offline on the secondary, that doesn't necessarily cause an outage. Maybe if I'm got some reports that are going against the secondary, I have some issues there, but the primary system that's taking the read-write data on the primary is not affected if the secondary goes down. But if the cluster service on the primary goes down, we definitely have an outage. And quorum factors into that, and we'll talk a little bit more about quorum here in a minute. But basically, because the cluster tells SQL what to do, when to bring an AG online, when to take it offline, we have to listen and follow what the cluster says, because the cluster is the ultimate arbitrator to say node 1 is the primary as opposed to node 2 or 3. And if we don't follow those rules, then we can run into a split brain scenario. So we have to listen to what the cluster says. And if the cluster goes down, we go down. Now, this is going to be a little bit different in SQL 2017 or vNext or whatever we're calling it. When we release the Linux version, there will be some differences in how that works, and I'm not really prepared to discuss that today. But just know that we won't have Windows clustering in a Linux world, so things will be different with the Linux version when it's due out. Anybody have any questions so far about how SQL interacts with the cluster and SQL's dependency on the cluster? Okay, I'm not seeing any in the chat window, so we'll keep going.
Okay, so we just had a question come in.
Could you repeat, please?
Oh, I'll say we had a few that were trickling in.
Okay, go ahead. I haven't seen them on the chat window. So.
You know, we can help monitor that for you, Tracy, to make it easier for you. A couple of these I think are going to be real easy for you. So, for example, does RHS have a GUI? How do you monitor RHS is what I think they're looking at asking.
RHS does not have a GUI, but I will show you some clues to look. Well, it does and it doesn't have a GUI, and I will show you that in the failover cluster manager in a little bit when we get to the demos. It doesn't have a GUI by itself, but there are some options that you can check in failover cluster manager.
Okay, great.
Other questions at the moment?
The other we'll hold off on for now. Okay. I think you're going to answer them a little later, or at least provide more context with them.
Okay, sounds good. So continuing, we're going to talk about the resource control manager, which is a thread within the cluster service that is responsible for resources. The resource control manager is what actually decides if a resource should be online or offline. And so if the cluster tells a resource to come online, it's doing it through the resource control manager. There are some other properties to the cluster service. The replicated store, so basically the state of the cluster is replicated to all nodes in the cluster. We don't have just a central repository anymore where the cluster brain sits. It's replicated across all nodes. And then we have membership and communication functions in the cluster service. These are things like the heartbeats, checking to see if nodes are available or not, and am I able to maintain quorum. Basically, this part is the crucial part as to what is the state of the cluster. Is it up and running? Are all my nodes healthy, and that sort of thing. But it's not checking the specific health of individual resources. The resource control manager does that, and he takes the RHS process, the RHS EXE itself, to do that. I can have, as this slide indicates, I can have multiple RHS EXEs running at the same time, and I'll go over that with the failover cluster manager in a bit. Each RHS process is going to have a set of cluster resources that it's going to look for the health of those resources. And there's always two functions that are always done with every resource, including a disk and an IP address. The first one is called looks alive, and if you've dealt with SQL clusters for any length of time, you're aware of this. Basically, the looks alive portion just checks to see if a SQL service is running or not. If the SQL service is actually running, we just say it looks like it's alive. But then we follow up with an is alive check to determine if it really is alive or not. And in SQL 2008 R2 and earlier, we would just connect, we would have the cluster connect to SQL and do a select add at server name. And if it got a result we would say, oh, it's alive. It gave me back a result set to my query, so we know it's good. In SQL 2012, we introduced more diagnostics for this is alive check, and we'll go on to the next slide to kind of talk about that. So the RHS process now, instead of just connecting into SQL, and doing an add server name, it will connect to SQL with one static connection. It connects at the beginning when it brings the cluster online, when it brings the availability group online, it connects to SQL and never disconnects. So it's not a stateless thing. It's like a fat client. It connects and stays connected, and it calls SP server diagnostics. By default, it calls that with a parameter of 10, which basically says every 10 seconds, return information back to the resource DLL. So go from SQL and return back to the resource DLL all this diagnostic health data that we're going to get. And that happens every 10 seconds by default. We only make one stored proc. It's an internal stored procedure. You can call it yourself and demo in a little bit. But basically, that stored proc returns the health of a bunch of different things. And if you call it with a parameter of 10, it never exits. It stays in an infinite while loop, and every 10 seconds it just spits data back to the resource DLL. At the same time, we also create a hidden extended event session called the diagnostics data, diagnostic health XEL. And the information that is sent back to the RHS process is also dumped into an XEL file. And I will show you where that XEL file lives and what's in it. It's truly the best black box that you have for SQL, the flight data recorder, if you will. If the server crashes and you want to know what was going on, that diagnostics data has got a lot of information in it, and we're going to go through that as well. And I've got some scripts to help you go through that too, that you will get. So instead of just a simple add server name, we basically go and we check the health of systems. Now, what is health? Well, we give you the ability to determine what healthy is on your determination. Basically, you get to choose what is considered healthy and what isn't, to a certain degree. We have what we call now the flexible failure conditions. The lowest failure condition, or the least restrictive, basically it does the least amount of checking, is level 1, which essentially is the same as in the old cluster stuff, looking to see if the resource, if the service is just running. So basically it's just checking to see, is the service running or not? And if it is running, it's going to return true all the time. And even the is alive check will return true. So we're actually not even doing a real is alive check, but we're always going to say, if the service is running, we're calling it alive and we're calling it healthy, and that's the end of the story. So it doesn't really check much at all. Oops. Layer 2, level 2, basically is what we had with SQL clusters 2008 R2 and earlier. We basically just look, are we getting any data back from the SP server diagnostics? We're not going to analyze the data. We're not going to look at it. We just, am I getting a result set back from SP server diagnostics? If I don't, we declare it not healthy, and we start the process of whether or not to fail over or not. So that's essentially the select add server name. We're just getting the data, but we're ignoring it. Are we getting it or not? Level 3 is and level 3 starts actually legitimately looking at the data from SP server diagnostics to see, are we having some failure conditions? And at layer 3, basically we've got some checks. We look to see, are we having a lot of SQL dumps taking place? Specifically, if we've had more than 100 SQL dumps and 2 in the last interval, then we're going to say, hey, this system is doing too many SQL dumps. There must be something wrong. We're going to declare a failure condition. We also look for buffer overruns, and we look for orphaned spin locks. Any of those type of scenarios is going to cause a failure on the health checks and cause the cluster to intervene and do something. At layer 4, we get, and all of these are cumulative. So layer 3 does all the layer 2 and layer 1 checks. Layer 4 does all the ones below it. Layer 4, we add one additional check. We look to see if we're having any out-of-memory errors. If we have out-of-memory errors, then we will initiate a failure condition. And then finally, level 5, we start looking at, are we having unresolved deadlock schedulers, unresolved deadlocks, things like that. So we start looking at the health of the query processor and the query engine at layer 5. It's the most sensitive and would cause failovers to happen potentially more frequently than, say, layer 3. So the higher up you go, the more sensitive and the more potential you have for a failure condition and a failover. So this will be another good spot to take any questions that have come in regarding flexible failure condition or the interactions with cluster. All right, we'll keep it going then. Yep. Or do we have something?
We have a question I think you might address later. So
okay,
that's all right. It for now. Let's just keep going.
All right. So that was the health checks.
Hang on, one more just bubbled in. Okay. They asked, what is the default failure condition there?
The default failure condition is level 3.
Okay. Cool. Thank you.
My laser pointer isn't showing here.
Hey, Trayce.
Default layer 3. Yes.
Can I throw one in for you that I think people may be wanting to know? How often would you recommend changing the default here? And is there any particular reason you see consistently that would cause you ever changing your default failure condition setting?
Sure, excellent question. For troubleshooting purposes, I might lower it. For instance, if I have some lease timeouts or I have some sort of performance condition on the box where the box kind of becomes non-responsive for a little while, and maybe the results from SP server diagnostics aren't coming back in time, I might drop it down to level 1 just to say, if the service is running, I don't want to die, don't kill me, and let me figure out and troubleshoot these performance issues. Because if it indicates a failure, the availability group goes offline. And so if you've got these, you've got a process at 2 o'clock in the morning that just goes crazy for 4 minutes, and all of your CPUs are pegged for 4 minutes, and then it dies and goes away, and everything is fine after that. Well, you might not want to cause a failover just because of that. So you could drop your failover condition level down to 1 or 2, and survive that sudden spike of activity, while you can then troubleshoot and see if there's something that you can do to improve it. On the other extreme, on the other end of the fence, let's say that I have a system that is extraordinarily heavy. I'm doing 50,000 transactions per second. I'm doing 80,000 transactions per second or something, and I cannot afford to be sitting here waiting for 2 or 3 minutes for something to figure something out and kind of get all hung and everything else. At the first sign of a problem, I want to just fail over. I would rather fail over than to limp along for an extended period of time with a bad condition. I might want to move that up to level 5. to be very sensitive and to fail over as quickly as possible. That is extremely rare. I've only encountered one customer in 5 years that wanted a higher than the default of 3. Usually anybody, if they make a change at all, it's to drop it down to 1 or 2 while they're troubleshooting some other issue. We generally recommend leave it at 3.
Perfect. Thank you, Trayce.
Sure. So we've been talking about the health checks. The other part of the equation in interacting with the cluster is the lease. So the RHS process, again, makes a lease with SQL. So what do we mean when we say a lease? Well, SQL has the ability, well, the Windows operating system gives you the ability to share memory locations. If you've ever used shared memory to connect to SQL, like with SSMS or whatever, and you're using a shared memory connection, that in fact is doing that. There's some memory that's shared between SQL and the client so that we can be faster in getting data back and forth from the client to SQL. So there's this concept of shared memory. So another process can share memory with SQL. And in this case, we set up a little bit of shared memory between the RHS process and the SQL process. It's not very much. It's only a handful of bytes. And another thing that can be done is you can set triggers, if you will. Think of it as a trigger. You can set triggers on these memory locations that say, all right, if SQL updates this memory location down here, it's going to trigger the RHS process to wake up and go and do the same thing. And so SQL will write to its memory location. That will trigger an event on the RHS process thread. That thread will then go and say, oh, well, SQL just responded to me. I need to go respond to SQL. So I'm going to go right to my memory location, and that will trigger SQL, and the whole process just starts over again. So this is a never-ending loop. They ping pong back and forth forever. The default timeout for a lease is 20 seconds. Every 1/4 of that interval, whatever that timeout is, every 1/4 of it is we're exchanging data in these shared memory locations. So basically every 5 seconds, we are pinging each other back and forth to say, I'm alive, are you alive? Yep, I'm alive, are you alive? And that's all they do forever. As long as that primary is online, that lease is going to be online doing that. And like I said, it's every 20 seconds. And well, the lease timeout is set for 20 seconds by default. And so every 5 seconds, we're updating the lease back and forth. Any questions about the lease? That's usually where I start having some questions.
Actually, the one question we did have, which you just answered, was what was the default value for the lease timeout and health check time? Are there any recommendations for it other than the default?
Yeah, the recommendations are to leave it the default unless we tell you otherwise in CSS. The default for the health check timeout is 30 seconds, and we check every 1/3 of that interval. So every 10 seconds, we're getting data back and evaluating the health. And for the lease, the default's 20 seconds. Every 1/4 of that interval, so every 5 seconds, the lease is renewing.
Okay, someone else is asking, where do you change these timeout values if you want to do that?
I will show you when we get to looking at the environment here in about another 4 minutes, give or take. We will start, and I will show all of that. It's a property on the availability group resource in the cluster. Okay, so we've kind of talked about the dependency between SQL and the cluster, and we've gotten to the point where if the cluster is not healthy, SQL is going to go down. If SQL is not healthy, we're going to go down, and basically the cluster is telling SQL what to do. So when we start having availability group failures, failovers, or even just going offline and coming back online and not failing over, we need to start figuring out why. And so my methodology has been, because I would get a lot of data sent up from the customers, I try to be efficient. Customers are always wanting to know as quickly as possible, why something happened. So I kind of felt that this was the most efficient way to try to find out why I had a failover or why I did not have a failover, or why did my availability group go offline. The AlwaysOn Health extended event session. It's an extended event session that is created by default when you use the wizard to create an availability group. It does not have to be created at all, or you can delete it. If you're creating your own T-SQL scripts to create your availability group, or using PowerShell to create your availability groups, and you don't create these extended events for AlwaysOn Health, you're not going to have them. I highly recommend that even if you script out your environment and don't use the wizard, that you get a script from another environment that has the AlwaysOn Health, like a dev environment or something where you did use the wizard. Get that script and put it in production and have it running all the time. Because the AlwaysOn Health extended events gives me a lot of information, and specifically it tells me when and what something happens. It doesn't usually tell me so much the why, but I definitely get the when and the what, and steps for me to figure out why. Because usually when I get data from a customer, I don't even know when or what happened. The customer may tell me a few things, but sometimes they're confused, or they don't have all the data or whatever, and I have to sift through a lot of data, or they might want me to go through the last month's worth of data and figure things out. So I have to figure out what happened and when it happened, and the AlwaysOn Health files tell me when to do that. The scripts I've given you will give you your times in UTC time. Sometimes it's as simple as someone issued a failover command. So if we have DDL statements in there that track if someone actually issues a failover from within SQL or PowerShell, if they fail over the group, there will be an alter availability group command in there. If I have a lease timeout, I will see that real quick and easy as well. Other types of things that I will see in the AlwaysOn Health events, for a given availability group, I can see I move from state to state as things are happening. So here at the beginning, you can see I'm going from not available to resolving normal to primary pending to primary normal. So basically you can see on those first three entries at 16:14, my availability group was coming online. If I ever move from primary normal to something else, that means my availability group went offline. So if you see a message that says primary normal as the previous state going to resolving normal, anytime the availability group fails over or the AG goes down, you're going to see that event. So I know exactly from right here what happened. I said my availability group went offline at 22:19 on October 1. And then from there, I can start figuring out more information. If I look here, you can see here in this example, I went from primary normal to resolving normal at 10:03 on October 3rd at 4:29 a.m. UTC time. Adjusting for local server time, which the SQL error logs show, you can see basically at the same minute and second, that Windows Server failover clustering node is no longer online. So basically I have a message here that the cluster went offline, and you can see the next message in the SQL logs that says the Windows cluster node has lost quorum. And then of course you can see that it went from primary normal to resolving normal. I like to use the X events to tell me what and when over the SQL error logs. I can get it from the SQL error logs most of the time, but it's a lot harder to sift through the SQL error logs to find out that I went from primary normal to resolving normal at this time, as opposed to just querying these X events, and I can see exactly when that happened, because I can filter those out and make it real easy to find out when. In this particular case, to complete this walkthrough, you can see in the cluster logs, remember, we depend on the cluster, so the cluster logs are going to be a really important source of information. And I'm not talking about just the event logs for the cluster. I'm talking about the actual cluster logs themselves, and I will show you how to get those. You can see here in the cluster log that we have 2 consecutive heartbeats that were missed, and that that's typically the reason that leads up to quorum loss is network connectivity issues. And so I can say back to my network folks, hey, we had a problem at this time. You guys need to go back and figure out what was going on with the network. So in this particular instance, I know that I failed over at a given time, or at least I know that my availability group went offline on the primary at a certain time. And then I can see from the SQL logs that I lost quorum. I can also see that I lost quorum in the cluster logs. And these consecutive heartbeats missed tells me that I'm having some network issues. So I don't know why I'm having the network issues. I could be having a problem with a McAfee host intrusion detection system problem. I could have a firewall problem. I could have network teaming problems between active-active or active-passive NICs. I could have a bad cable, a bad switch. There's a ton of things that could be going on layer, but ultimately my quorum was lost on that node of the cluster, so it lost connectivity to everybody else, and that's why it took the availability group offline. And then let's just take one more look here kind of at the cluster log anatomy. What you're going to be wanting to look for are a couple of things. One, you're going to want to look for error messages. In this column, it'll have an ERR when it's an error message. Typically, errors and warnings are what you want to look for. And over here in this first column, though, that one is kind of important as well. That one's the process ID. So we talked about the RHS process. It's running, it's an executable just like any other executable, and it has a process ID. Sometimes that process ID will help us when we're digging deep on specific things. And so sometimes that process ID will be helpful, and that's the first part of the log. And then the only other, well, obviously the timestamp is important, but then we also have the text of the log itself in this rightmost column. So those are kind of the main pieces of the cluster log. So with that, if there's any questions that come in, I'm going to switch over and get my demo going for going through different things. So we got any questions at the moment?
We've kind of a general one, which I'm guessing you can answer. It says, how well does an always-on availability group work over a WAN link? For instance, we have a data center in Alaska and another in Virginia.
So the typical problems that you're going to have with a I call it a stretched cluster that's really stretched far, like that, is you're going to have cluster heartbeat issues. Cluster heartbeats are happening 5 times per second. Basically every 200 milliseconds, a cluster heartbeat is being sent out. And if that cluster heartbeat is not responded to within the appropriate time, it will declare that it has missed heartbeats. And if it's missed enough heartbeats, then it declares the server connectivity between those 2 nodes is down. And that's when it declares a node down. And then if you have enough nodes go down, your cluster goes down. So generally for large stretched clusters like that, we recommend relaxing the heartbeat settings so that we can afford to lose more heartbeats, and we can wait longer to receive the heartbeat response. So those are factors that can be tweaked, and we recommend doing that. But ultimately, you have to have stable network connectivity in your nodes of your cluster, or you have to take some of those nodes out of the voting equation so that they don't contribute to quorum loss just because you've got a bad network link between your primary site and your DR site. So if you've got a DR site that's really far away, you're having issues of cluster quorum, then increase the heartbeat thresholds so that you've got more resiliency there. But if that's not good enough, then you may have to take your DR nodes and not let them vote. They're still part of the cluster, but we don't want them to vote. And we could have a whole discussion just on quorum and voting. So if anybody wants, they could ping me and I'd be happy to talk to them about it. Y'all will have my contact information, so I'm happy to have a session on quorum just by itself. Okay, so we had one question about where do I change my heartbeat settings? Not my heartbeat, my health settings. So this is Failover Cluster Manager, and you can see here I've got an availability group, and it's running. If I click on that availability group down at the bottom, I can have the summary or the resources. I go to the resources tab, and you can see right here that I've got highlighted. This is my availability group resource in my cluster. If I right click that availability group resource and go to properties, and then go to the properties tab, I can see my defaults here. I can see my health check default is 30 seconds. It's in milliseconds, so it's 30,000 milliseconds. You can see my lease timeout, and it's set for 20 seconds. And you can see your failure condition level at 3. So if you want to change any of those, this is where you change them. The maximum on the lease timeout is 100 seconds, so 100,000. There's an undocumented way to make it higher than that, but we don't recommend it. The health check timeout, I don't know that we have a maximum for that. I've made that one pretty high before, so it can be pretty high. You just have to know that if you make those things higher, then it's going to take longer for a failover to occur. So that's where you change them. Now, I know a lot of people that have done a move group from the cluster like that, just like you're used to with failover clustering, right? You can see here, here's my group. Here's my current owner of my node, Site1 SQL 4, and I just moved it, and I'm going to move it back to SQL 3. Okay. Under most normal conditions, that's not a problem, but that is not the official way to do it. The official way to move an availability group is via Management Studio, T-SQL, PowerShell, which ultimately comes down to a T-SQL statement. So don't move it from Failover Cluster Manager, and but I am going to do one condition here that I'm going to create a new database. Let's just do a new query here. Create database, DB2, whatever. And I'm going to back it up. Don't do this at home, boys and girls. Okay, and now I'm going to add that database to my availability group. Okay. Oh, it's not in. Oh, yeah, it meets requirements, so I'm going to add it. And I'm just going to do a skip synchronization for a moment. Don't do this at home either. And I apologize, my virtual machine is going a little slow here. It shouldn't take that long. Okay. Okay. Now, if I look at my health of my availability group, I'm going to see that I've got warnings on my DB2 database here because they're not synchronizing. Because I told it to not worry about getting the database over there. I'll do that myself. Well, I haven't done it yet. If I go back to failover cluster manager and I try to fail this over to site 1 SQL 4, you can see that it's pending, and now it's back up on site 1 SQL 3. So it actually failed to fail over. That's one of the common reasons for failure to fail over, is one of the databases is not synchronized. Well, how would I know that and see that? What would tell me that? First of all, I'm going to show you how to get cluster logs. This will be your friend, get cluster log. All right? It's going to store, by default, it will store the cluster log in the Windows Cluster Reports folder on each node of the cluster. So if I just do get cluster log and I do a time span of, say, the last 10 minutes, it's going to store that file, and it's going to be called cluster log, cluster.log. It stores that in the Windows Cluster Reports folder. So you can see that file right there, cluster.log. It's helpful and oftentimes necessary to get the cluster logs from all of the nodes. So when you do a get cluster log, you can also use the destination command and tell it where to put it. And again, I'm going to get the last 10 minutes. But you can see here I've put a dash destination temp on there. And what that does is it's going to copy all of those logs from all of those nodes into that temp folder, and it's going to prepend them with the node name so I know which file is from which node. So when I need to be going through cluster logs, I want to use the dash destination to bring them over for me into one spot, and I can do the time span. I can also use local time. Instead of having it be in UTC time, I can have it be in local time. I've gotten so used to doing it in UTC time, I just leave it like that. So that's one source of information. But let's crack open. We tried to fail over to site 1 SQL 4 and it didn't. So let's just crack open that log real quick. Yeah. And because I know, well, let's do this. One of the things that I search for, and I'll give you a list for the things to search for, is header AG. And you can see here a bunch of statements about SQL availability, SQL Server availability group stuff. And you can see here that it's connecting, establish a connection, that sort of thing. If I see here, you can see here an ODBC error, failed to blah, 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 blah. And we can see here, where is it here? No, I thought I saw it. go. One or more databases is not synchronized. Yeah, it's on there. So basically, it failed to execute a command. The command that it failed to execute was to bring it online. And the reason basically it says here, one or more databases is not synchronized. So that's why it failed to fail over. But you notice that was in the cluster logs. So a lot of times what you're going to be wanting to look for is the cluster logs. Because the cluster is what tells SQL what to do. Now, let's go back to my methodology here. This is the AlwaysOn Health XEL. Just loaded up one of the XEL files. And if you actually, all right, where are the XEL located? They're in the log folder. They always look like AlwaysOn Health XEL files. But your black box files, I mentioned those, are the ones that say system health.xel. And then we also have diag ones. And if we have some time to go through those, I will show you those as well. Those are all stored by default in the same folder as your error logs. I don't like looking at them through the XEvent viewer in Management Studio because they're a pain to sort out. So I've written a bunch of scripts that will get this information and give it to me in tabular format so I can look at stuff. So basically I just run this script and it's going to go through and parse those AlwaysOn Health XEvent files. And when this comes back, you can see normally it doesn't take this long. Okay, let's do this because this is, my screen's getting too big here. But okay, if I go down to the bottom, the last result set that it shows is it shows all of the XEvents that it monitors and the count of each. So you can see here I had a bunch of, trying not to move it around. I have a bunch of events of error reported. You can see some DDL executed, which means that somebody changed an availability group somehow. They added a database, dropped a database, or they did a failover command. Those all show up under DDL. You can see I have lease expireds events because I was messing with my system and caused a lease expiration. So you can see real quick when things happen. If you start looking at here, see here's all the lease events and the times that they took place. So and the availability group involved. So if I had a lease expiration, I can then take this timestamp and go to my cluster logs and see if I got more information to look at. Or I can go to my SQL error logs and say, hey, what happened around this time? Why did I have a lease timeout? If you're having lease timeouts, they're almost always a performance-related issue if you're having lease timeouts. Because the lease thread in SQL is a high priority thread that can run on any CPU core. It's not like a regular user thread doing a query. It's a very high priority thread and it can run anywhere. And for the SQL not to respond to the lease, there's something really wrong with your OS as a whole. There's some sort of performance problem, or maybe it's a virtual machine that's being frozen for a minute while a backup of the VM is taking place, things like that. Another common one is a SQL dump, because when we do a SQL dump, we freeze all of our threads. All right. I know I'm running out of time. I will just show you in here I have another script to shred the diagnostic files, and you will see you don't always have that information from all the different things, but you'll see query processing events. You can see how many workers you have created, how many workers were idle, did I have any non-yielding schedulers or not, things like that. So you can kind of get health of how the system was performing. I can get memory state and things like that from these as well. So there's a lot of different information that I can get from these diagnostic files, and the system health files are virtually the same as well as the diagnostic health files. It's just that the system health are recorded every 10 minutes, and the diagnostic health files are recorded, I think, every 20 seconds or every 30 seconds or something. They're recorded a lot more frequently. The demo code will be shared, I guess, let me just put up my final slide so you can get my contact info, and of course it will be in the slides as well, but there's my contact info if you want to get it. And I want to thank you for your time today. Hopefully I gave you kind of a taste of how I did it. Oh, there is one other thing that you will get in the data that I give you, and that is I have a series of scenarios where I've already collected all the logs. So like here I've got the cluster logs and the AlwaysOn Health data and that sort of, and the SQL error logs. And for each of these scenarios, I ask you to find out a bunch of questions. And I give you the answers as well, but I give you, these are things you're going to want to search for in the cluster logs. These are things you're going to want to search for in the error logs, SQL error logs, and things like that. So if you go through these scenarios, you can also get some practice about my methodology to find root cause analysis. And with that, I will end because I'm 1 minute over.
Awesome. That is great, Trayce. I'm sure everyone will benefit by going through those exercises there.
Yeah, my pleasure. And if any of you ever have any questions, feel free to reach out to me. You can reach out to me at Microsoft or personally on that seekwellandprosper.com. I don't blog on there as often as I will eventually be blogging more, but don't have the time right now. So, but feel free to reach out to me if you have questions, and we will get in the scripts and everything uploaded so that you have access to them.
Yep. Someone asked if this is being recorded, and if so, how can they access it? And yes, it is. We'll get this up on our YouTube channel here in a couple of days, and then when Trayce sends us the code, we'll add it as an attachment on the SQL Pass website as well, and put a link in the comment section of the YouTube video for it as well. Let me see. I think, Bob, are there any other questions you saw that you thought we should throw in there real quickly?
Most of the questions I've seen have come in have just been thank you very much and great job, and how do we get the material, which we've already answered. It'll be posted up on our site. We had one technical one here. The cluster.log has to be created each time. There's nothing there to monitor it by default.
Correct.
Okay. That is it for questions.
Yeah, whenever you have an event, as soon as you possibly can, get the cluster logs and save them off, because the cluster logs will give a lot of information.
Okay, that is great to know, actually.
Yep. And I love the time span too, so you don't have to get all the details, just the detail right before your issues occurred.
Correct.
Cool. Alrighty, with that, we'll close out today's meeting. Trayce, thank you once again for joining and sharing your knowledge with us, and we'll see everyone next month.
All right, thank you.
All right, bye guys.